Assalamu alaikum friends, welcome back to the channel. Younes Charfaoui is here, and in this video we are going to see how you can convert callback implementation into suspendable computations using coroutines. Let's get started. So here I'm having fresh Android project here, and I did some code here. I will show to you. This Firebase Firestore is just for the sake for the presentation, and I am doing everything here in the main activity. Normally we shouldn't do that. We should have an extra layer for remote thing like this Firebase Firestore. We should have like view model and everything, but I'm doing that just for demonstration. So don't do that in your base code. So here I'm having just the Firebase Firestore, which is my remote database. So as I said, this is just a demonstration. We won't be having this collection username and everything. This is just demonstration. So I'm having a function called get data from Firestore, in which I will just check the collection and do a query based in that collection, like for username, search for me with username, with value, it's Younes. And we will get the data. And normally for such thing like Google Play services and everything, as you can see, it will give a task in which you can add success listener, failure listener. There is many listener, I think, complete listener, cancel listener, and so on. So usually we use this too. And if it is success, we will just pass our callback here on success, whether the user exists or not. So if the result is not empty, we simply here you will get the callback. This lambda, you get the callback, and you will see like the user exists or not. The same thing for the failure, we will pass the exception here and we will print it here. So this is the simple callback implementation. Now let's say we want to convert this into suspendable computations. So the first thing we need to do is like here we should use like suspend. That's the first thing. Now we will get an issue here, we will try to solve it later. So here we need the continuation to suspend the current coroutine. So the continuation is the bridge between the callback word and the coroutine word. So we use it like the following. We need this suspend coroutine block. This one, as they said here, it said obtain the current continuation instance inside the suspend function. So we need that for that reason. Here we should put like our return type, like this Boolean type. And now it will be our continuation. Let's name it continuation, like that. And we just need to put our code here, but we need this continuation in order to resume the execution. So instead of doing on success here, we will do the following, like this on success is my callback. I will delete those. We don't need them, like the following. And here, instead of passing that, we will do continuation dot resume. We resume like the following. And here you can resume with always the same thing, like this one from the it dot is empty. Now in the failure, you can also resume. Let's say you want to resume with the false because it didn't work, for example, or you can resume with an exception. So this function will raise an exception if you have a failure, and you can do like the following: resume with exception, and here you will put just like the 8. The 8 is my throwable here, and now you can just return this to the return type here, and it is Boolean. Like you can delete that because it knows. Now this gets data from Firestore. Now it returns what? It returns the Boolean directly. Now what you will put here, you will delete that. So here I have created a coroutine scope, like to use dispatcher, IO, and the job. And this job, you can use it like, for example, to cancel this coroutine here. Now, in order to run this coroutine, like you need a coroutine scope, that's why I created that. And boom. Like here, usually we do that like in the view model with view model scope, so we get back the result and you push that result from the UI like using live data or any other mechanism. So this is how you can convert this callback implementation to using coroutine. So there is a problem, not a problem, but something you need to be aware of. Like let's say that after some minute, I will have to decide to cancel this job. Now, when you cancel this job, this coroutine will get canceled, but there is no way to cancel like this downloading. I don't know if you can do that or not, like cancel it or not, this computation here. Like usually when we work with retrofit or let's say something else, we can cancel certain things. So in order to cancel this one, you need to use suspendable, cancelable coroutine. Like this one will give you a block. We'll give you a block. Let's do that. Continuation called, let me check here, invoke on cancellation. So here it will give you a callback here in which you can cancel anything you want to cancel here. I don't know if you can cancel this call. I don't know if you can do that in Firebase or not. You can cancel it or not, but it gives you a way, like when you do this cancel, it gives you a way to cancel what you have been doing here. So that's the idea of suspendable, cancelable coroutine. If you go here, like it's suspend coroutine like suspendable, but providing incancelable continuation to the block. So this function throw cancelable exception if the job coroutine is cancelled or completed while it is suspended. And we use this suspend cancelable coroutine or suspend coroutine if you have one shot return items. If you have like multiple things, like let's say if you are getting data continuously, or let's say you are just listening to real-time database for Firebase, you will have to use callback flow. You have to use flow here in order to convert those callback implementation into flows. But using this block, it will give you only one return item for one shot. As they said here, a typical use of this function is to suspend the coroutine while waiting for result for a single shot callback API. That's the idea for that. And here they're providing the example for the API. As you can say, they can register that and they can remove a callback on cancellation. As you can see here, the API and register this callback. So this continuation invoke on cancellation will give you a way to cancel anything you are doing with your API. So keep that in mind. Okay, I didn't find an example here because I'm using Firebase. Now there is, I think, by default, if you do this, let me check here. If you go here, if you use this one Kotlin X coroutine play service, you don't have to do that by yourself. Like you need to do just an await, and it will do that coroutine for you. The whole thing we wrote, it is implemented for you. If you go here to the await, we'll see how it is implemented. Let's go to the await implementation. Like the first path, if it is complete, okay, so we'll do some optimization. Then, as you can see, they are using this suspend cancelable coroutine use. So they are using this one here in invoke on cancellation. That's the thing I was missing here. Okay, so they are doing like this continuation resume with, or continuation cancel, or continuation resume, as you can see. So this is just an improved way of how we did things here. So this will be used on any task because Google use a lot of this task in many places. So this is the code for their await. They are naming this function as an await. Okay, so it is general purpose thing. As you can see here, they're using this suspend cancelable coroutine, and add on completion listener is just the same as using on success and on failure. So if it is an exception, okay. If it is not, okay. And they're using this block in order to do something like when the coroutine cancel. So this is the idea on how to convert normal callbacks to normal coroutines. So thanks a lot for watching. I hope you understand how you can do that by your own. Thanks a lot for watching this video to the end. Don't forget to subscribe to the channel and see you in the next videos. Salam alaikum.